So welcome to part 2 of this video. In this video, we're going to talk about the Maclaurin series again, Taylor series. But the idea is I want to focus on this one. So what if we are asking Maclaurin this series, this function here, 1 over 1 minus x? Well, again, we know f of x is equal to 1 over 1 minus x. F of 0 in this case happens to be 1. Yeah, because if we plug in 0 in for x, we get 1. F prime of x, or the derivative, well, remember, we could rewrite this as 1 minus x. Well, so this is also equal to 1 minus x raised to the negative 1 power. Okay. And so if I take the derivative of that, that becomes negative 1. So if I take the derivative of that, that becomes negative 1 times 1 minus x. If we subtract 1 from that, we get negative 2 times the derivative of the inside. And so we know by the chain rule, this is equal to 1 minus x to the negative 2. To negative 2 power, so that's our derivative. And so f prime of 0 in this case, well, if we plug 0 into that, we still get 1. Okay. Now what about f double prime of x? Well, derivative of this one, well, simply if I bring my 2, I'm going to bring my 2 down. This becomes 1 minus x. If I subtract 1 from that, it becomes negative 3. Okay. And I simply multiply by the inside, the derivative of the inside, which is a chain rule, so that will give me a positive 1 minus x to negative 3. So that's my derivative. So f double prime of 0 in this case, f double prime of a, okay, in this case will actually be what? Well, if I plug in 0 in for that, hopefully we can see that we'll get 2. Now what about the third derivative, f triple prime of x? Well, it looks to me that I'm going to have 2 times negative 3 times 1 minus x raised to the negative 4th times the derivative of the inside, which is just negative 1. So this becomes 2 times 6. What is 6, man? What? 2 times 3. This becomes 2 times 3. I'm sorry about that. So this becomes 2 times 3 times 1 minus x to the negative 4th. Okay. And guys, do not multiply these because I wanted to show you a trick with these things here. So what if we wanted to find the fourth derivative? Well, it looks to me is that if I bring this down, this becomes 2 times 3 times negative 4 multiplied by 1 minus x raised to the negative 5. And we multiply the derivative of the inside, which is just negative 1. Okay. And so in this case, we'll get 2 times 3 times 4. And this is equal to 1 times 1 minus x to the negative 5th. So that's our derivative. That's our fourth derivative. And so, yeah, I did not evaluate this. So f triple prime of x in this case, well, it looks to me is that the general pattern looks to me as if we're getting factorials here. So 2 times 3, this is actually 3 factorial. And this is the reason why I encourage you guys not to multiply these out as you're doing the derivatives. And so f, the fourth derivative in this case will actually be 2 times 3 times 4, which would also be 4 factorial. Okay. Now, in case you did not know, this is 2 factorial, okay, because this is 2 times. This is 1 times 2, okay? So you could get the general gist here that these are factorials. And so this is the reason why I encourage you guys not to, when you're taking the derivatives, do not multiply them out because you want to see these patterns. And once you see these patterns, it makes it easier for us to evaluate. And so we know the general formula now is given by f of x, which is equal to f of a plus f prime of a divided by 1 factorial times x minus a plus f double prime of a over 2 factorial times x minus a squared. And again, we could go to the third derivative, x over 3 factorial times x minus a cubed. Okay, we could go on and on and on. And so plugging in everything into this formula, well, what do we get? Well, it looks to me as if my f of x in this case, my f of a happens to be 1. So this is 1 plus f prime of a also happens to be 1 times x minus a, which is 0, over 1 factorial. My 1 should be here, but that doesn't matter in this case. And what's my f double prime? That happens to be 2 factorial. So this is 2 factorial. You're going to divide that by 2 factorial times x minus 0 squared. okay? And this becomes, well, f triple prime becomes 3. This is 3 factorial divided by 3 factorial times x minus a. Well, in this case, a is 0 again. And we're going to cube that. And again, we could go on and on to 4 factorial and all that stuff, okay? And so if we want to simplify this, actually, this becomes 1 plus, well, x minus 0 is just x divided by 1 is just x. And again, you could see that 2 factorial and 2 factorial will cancel out. So the only thing I have left is x squared. 3 factorial and 3 factorial will cancel out. So the only thing I'll have is x cubed. And you can see that I'll eventually go to x to the 4th and eventually x to the n. Okay. So how can I write this as a sum representation? This looks to me as if, well, my first term is a constant, so I don't have to write it. Okay, so this looks like to me that I have from n is equal to 0 to positive infinity of x to the n. And this will be my sum representation. Now, had this been a 6, I had to put my 6 outside here because it's not 1. And so this is a video series for the Taylor Maclaurin series expansion. Again, nothing too hard.